So let's just see here. This is the FCP models. So the blue one, I think the middle one should be in different colors, but it's fine. So if you see it from here, you see a hexagonal, 六边形. Okay, so we have six corner atoms for this plate, and also one face atoms. And for this structure, we have two planes, right? This is the first plane and the second plane. And also we have the orange atoms. And these three orange atoms, they are entirely inside these unit cells. So it will belong to the interior atoms. Okay, we will need it for this calculation, number of atoms in unit cell. So you can first see it from this surface. We have hexagonals that we have, I think, 7 atoms. These 7 atoms are in a close packed way. So that's why we call this structure as close packed. And we add the name for it, hexagonal, because the shape is in a hexagonal. So we call it hexagonal close packed. And because this structure is complicated, so it will be better for you to use this model to know the relationship. Okay. In other words, you just pick any atoms. You pick any atoms and count the number of atoms. For example, we pick these ones and we find out how many numbers that is in touch with these atoms. So again, you must use these models so you will understand that which ones is in touch with which ones. So for this plane, we call it XY planes, we have 4 atoms, 1, 2, 3, 4, that are in touch with this one. So we have 4 atoms on this plane. How about below this plane? So below this plane, we have 4 face atoms, okay? And I think you can try to see it from this model or from the real models. So these 4 faces, these 4 face atoms, they will also in touch with these ones. And also, we have already discussed this plane and below this plane. How about above this plane? So we have 4 more. So you will find out we have 4 plus 4 plus 4 equals to 12. So this is this one. And you may think about it. I choose this one to calculate. Can you choose this one or this one? Yes, and the results would be the same. And the reason is, actually, the face atom you see here, or here, or here, and also the corner atoms you see here, they are actually the same. And the reasons, you must understand the crystal structure and unit cells. This is a unit cell. So we just try to find out the smallest repeat of the structure. So this unit cell is inside this structure. So if I cut this unit cell out, we define this atom as corner atoms. But if someone else cut the other unit cell, maybe for example for this one, we choose this as the corner atoms, then actually you will find out the same result. In other words, we define this as the corner atoms is because we cut it from these unit cells. If I shift a little bit, I will find out the other unit cells. So the fast atoms are actually the same as the corner atoms.
因为如果你用的这个东西，你会考虑你的就是
没有先可以先不用管它，因为我只是要把 H 描述出来，只要先知道 H 怎么搞。
PBL question types. Okay, so and now I will ask you a questions. How to keep high temperature phases? Now we know the meaning of phase, right? For example, this is one phase, this is the second phase, the third phase. So the question is how to keep it in room temperature. For example, we know that below 912 degrees C, we have alpha iron. This is BCC structure below, right? So for room temperature, we should have BCC irons. But how to keep high temperature phase? For example, this one, gamma irons, FCC. If we first increase the temperature to this range, then it will change from BCC to FCC. But if we cool it down, it will turn back to BCC, right? But how to make this happen? For example, as engineers, we will say that perhaps the property of irons is better than that for the BCC irons. But how to produce material like this? So here are some backgrounds that you need to know before you think about it. So first, the meaning of high temperature phase means that this phase would be stable at high temperature. In other words, this phase is not stable at room temperatures. So this is about thermodynamically stable. Okay, so now you know about the questions, and I will give you around 5 minutes. You can think about it, and then you can also discuss with your friends. That's fine. And then to encourage you to answer the questions. If you answer the questions, I will give you extra 1 point for overall score. Say your opinions. I will give you 1 point. Okay? And now let's give you 5 minutes. If you have any questions, you can also ask me during this period.
Considered unstable, or is it like semi-stable?
Sorry?
If it needs like energy barrier to get
yes.
stable again, is it then still unstable, or would you consider it semi-stable?
Oh, you mean the status? We will say this as metastable.
Okay.
Oh, sorry, meta.
Material in the space which is not fulfilled and make it cannot. So the structure won't change when you change the temperature.
Sorry, could you repeat again?
Put new material in the space.
Space. Space?
In the structure which is not fulfilled, and fill in, and when the weather change, when the temperature change, the structure won't change.
Put it in the space. In what space? It's okay. It's very good. Very good to try.
The APF that
If you want to say in Chinese, it's okay. I will translate it for
那个
you.
结构还没有被填满的地方，在里面塞东西，让它就是让它温度改变的时候没有办法，没有空间去移动这样。
You mean the space here?
Yeah.
Okay. Anyone want to try?